Here we're going to solve an equation that has two radicals in it. When you have two radicals in your equation, what you want to do is to get one on one side of the equal sign and one on the other. This one is set up that way already, but if they were both on the same side of the equal sign, you'd want to add or subtract and move one over to the other side. Once you have them on each side of our equal sign, then we want to undo the radical that's here. So I have a square root all by itself on the right. I know to undo that, I would square both sides. So the right side gives us a 10x plus 26. The left side, we need to think about what this represents. Outside of the radical, there is only multiplication for our operation. So this is just one big term. There's no addition or subtraction outside the radical, which means we can square the 3 and square the square root. You could also write this as 3 times the square root of x plus 3 times another 3 times the square root of x plus 3 and multiply it out that way. But with no addition or subtraction here, we can basically just square the 3 and square the radical. If you square the 3, actually, let me write this out in this step rather than just talking about it. So because the only operation outside the radical is multiplication, we can square both of those, which would give us a 9 and an x plus 3. Right now I have x's on both sides of the equal signs, and I'm trying to solve, so I want to get those all on one side. I'm going to use the distributive property to get rid of those parentheses on the left side of the equal sign. Then from there, I want to get all the x's over to one side. I see that if I subtract a 9x on both sides, that will give me a positive 1x, which would be good because I'm solving for a positive 1x anyway. And in my next step, I'd want to move all of my numbers over to the other side, away from where the x's are going to be. So either doing this in 2 steps or one bigger step, you can get your x isolated. Normally we would be doing a minus 9x and then in the next step a minus 26, but if you're doing addition and or subtraction 2 steps in a row, there's nothing wrong with doing those together. A negative 9x minus 26 on both sides, still doing the same thing to both sides. So that's a good step, and it saves us a step of writing. Over here the 9x's would cancel. 27 minus 26 is 1. On the right side, 10x minus 9x is a 1x, or just x, and the 26's would cancel. So we end up with something that is solved pretty quickly when we do those 2 steps. X equals 1. When you are solving radical equations, you do want to go back, look at what you raised both sides to as far as your power goes. It's an even number, so I do need to check my work. This might be an extraneous solution. So either the answer is 1, or this is extraneous and we would have to get rid of it. This is our only possible answer, and if we get rid of it, then the answer would be no solution. So let's check and see if x really does equal 1, and that's our answer, or if we end up with no solution on this one. So plugging 1 in for our x's, we would have 3 times the square root of 1 plus 3 is equal to the square root of 10 times 1 plus 26. We want to see if that's true or not. 1 plus 3 is 4, and the square root of 4 is 2. And 3 times 2 is 6. On the right side, 10 times 1 is 10, plus 26 is 36, and the square root of 36 is 6. So that does verify that 1 is a solution for this problem.